So what we'll be doing today is we're going to look at pandas. And the next week here with me, I also have Dr. Mahmoud. Dr. Mahmoud is also a colleague here. He's assistant professor here at the University of East London here in UK. He is working on teaching in AI and data science. So next week he will be able to, talk to us, possibly data preparation and also visualization. So these two things next week, Dr. Mamu will take us through. But for today, we have Pandas, which Lukman will take us through. And yeah, I think that's what I have. But also, we also have everything you want for this. Like if we presented some notebook or something like that, it will be in this folder. So here in this folder, you can see we have the book Python for data analysis that we talk about. Here you can take, clone this repository and you'll have this book. You can see it, Python for data analysis. The first lecture I did, Introduction to Data Science, you can see it here. And also we will upload the material that Lukman did in this folder. Yeah, so I think without much further ado, I will hand over to Bala to take over this explanation and about everything about mentor and mentee and also anything related to the fellowship. So thank you very much for maintaining this uh, team, Abdul Jalil, and it's over to you. Thank you.
Assalamu alaikum. Can you hear me?
Thank you.
Okay. It's my pleasure to be called for this, and I'm so sorry to say that what we planned for the fellowships, actually, the time duration has been longer. It's not from our end, but I believe it's worth watching. So at this junction, I would like to discuss about the issues of mentor-mentee, which we decided to pair each fellow with a mentor that will guide him in any progress of his academy here. So each fellow is paired with a dedicated mentor who will offer personalized guidance on the weekly assignments. And then we also provide concept clarification. For instance, if you have any problems or challenges and you need clarifications about it, you reach out to your mentor and monitor overall progress of the fellow. So each of these fellows is expected to submit their assignments on time, which mentors review and give constructive feedbacks on them. So instead of the way we are submitting an assignment before, so now we have a mentor that is paired to only 5 to 6 fellow that will be submitting the assignment to, and he will be reviewing, giving feedback. So mentors will also be tracking each mentee's achievements, which include the course completions that we are currently taking in data camp. What is your project milestone currently, and the active participations, because we said attendance is one of the most key things in the academy. So also all these things is to ensure accountabilities and consistent growth. So the structures of the mentorship model encourage continued learning, also collaboration with the mentor. That you don't understand, so you reach out to your mentor for guidance, and that will also provide professional development throughout the program. So, but that is how the structure that we designed it for. We shares all the information with regard to that one last week. There was a Google sheet that I shared with you. You can check your name there and the mentor. And we're thinking of creating a platform for these mentors so that you can join, be able to reach out to your mentor, or the mentors can even reach out to you via the emails, because I've shared all the details with them. So be expecting to hear from your mentors after this. So that is all about the mentors and the DPR. But I would like to introduce a speaker for you, who is from Lukman. I believe he's not a new person to you. So he's a sessional person to us here, a data scientist and machine learning, who will be leading the sessions on this week 14 that we said on Pandas. So with an extensive experience in data sciences, machine learning, he has worked with numerous real-world projects involving data cleaning, transformations, and analysis. So we welcome Pharmacy Lukman. Pharmacy Lukman, are you ready? Hello, man, Lukman.
Yes, good morning, everyone. Thank you for the opportunity. So I'm back here again to discuss pandas, having discussed NumPy last week. Please, am I audible?
Yes, you are
Yeah,
audible.
loud.
All right, thank you. So having discussed NumPy last week, we are here back to discuss pandas. The plan was to discuss both last week, but as you all knew, there was a clash in the timing with the other program. So we are back here now. So let me share my slide. Oh, I can't share my screen. Okay, 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 okay. So we are back here to discuss pandas. So in this 1 hour, we'll try and understand the link between pandas and NumPy, and then how to create and load data frames using pandas, and then perform essential data frame operations. That's having understood the data first, because the first thing is to understand the data. Pandas is just a tool. So once you understand the data, it's very easy to use whatever tool. You can use pandas in Python. You can use R. You can use Julia. You can use SQL. Whatever. Mostly you perform similar operations depending on what you're working on. But you need to understand the data first, and then finally how to visualize data with pandas. So there's the dot plot function that you can call on your data frame, and then you use that. Though you still need to import matplotlib in most cases before doing that. So these are the things we want to run through within this short time we have, just as an introduction for people to understand what pandas is and how you can introduce it to your data analysis workflow. So the first thing is to understand. So, like we explained last week, Pandas is built on top of NumPy. So it means that there are a lot of things under the hood. It still uses NumPy. And even when you're using Pandas, there are things where you call some NumPy functions, because NumPy is really advanced when it comes to things related to numerical computing. And then another important aspect is that it provides a powerful data frame and series structures that you can use for your analysis. So look at what those are in time. And then there's intuitive data manipulation. You can manipulate your data frame, you can understand the data and do a lot of operations. And there's also supports input output from, let's say, CSV files. You can read CSVs, you can read Excel. There's a read SQL function where you just add your database and you can query it directly from Pandas. So Pandas is quite sophisticated. But as always, we'll only look at the basics, and then with time and practice, a person can explore more. And then finally, one of the reasons it's important in data science, finance, research, different aspects, because there's a lot of things, there are a lot of functions that are available and easy for use. So to install Pandas is quite simple. So I just use pip normally. For people familiar with Conda, you could say install using Conda, but using pip is more general for people who are not that familiar with that. So you open your Python and then do that. If you are using your notebook, you could just put that apostrophe and then pip install pandas. But if you're directly on your terminal, you don't need any apostrophe. Just put install pandas and pandas will be installed. So the next thing is to import. So you have to install the pandas first before you can import. And then to import pandas, you use import pandas, and the alias is PD. So most people use PD. It's not compulsory. You can just import pandas and use it like that. But just that anytime you want to call a pandas function, you have to write pandas dot and then call the function. So you can even use another alias. Maybe you want to install pandas as PA, whatever. But your code will not be usable. You cannot easily collaborate with others because they will expect pandas to be imported as PD. So you really need to explain if there's for any reason you need to change your alias. So as usual, numpy to as MP. So you mostly import them together, though you can still use pandas without importing numpy. But most instances depend on how deep your analysis is. There are instances where you need to use numpy functions. So it's very good to import NumPy. So even though we said that pandas work with NumPy under the hood, you don't need to import them together. But there are instances where you need to use NumPy functions. So that's why mostly you import them together. So the first thing is series. So we have two data structures in pandas that are native to pandas. That's series and data frame. The first is the series. So if you want to create a series, you use the pd.series, that's capital S, and then you put in. So the item you give in, the argument could be a list, could be a Python list, it will be a NumPy array and anything else. So here, just for illustration, we use a NumPy function. So np.random.rand. So that's why it was important to still import NumPy. So we have this generation of random numbers between 0 and 1, and then we added. It's just to show what a series is. So a series is a one-dimensional data structure. Let's say a one-dimensional array. So it's just one column. You cannot have maybe a two-column series or something like that. It just has to be one. So mostly you don't really need to create series. There are few use cases where you actually need to create your own series. But when you perform some operations on a data frame, it returns series. Maybe you just selected one column from your data frame, it's going to return a series for you, just that column, and it will give you the data type of the series. So for this series, data type is float. Mostly when you have optimized packages like this, all the data types are the same because that helps in making the computation faster. The calculations are fast and the computations are fast because it's the same type. So for this case, you have float before as a data type. Of course, it's a rand. We use mp.random.rand, but maybe we decided to just add some list and put different numbers. It's still going to change them to float if you have floats there because they have to be the same data type. And then the second and most important one is the data frame. So you have a series and a data frame. So data frames, you can create your own data frame yourself using the pd.dataframe function. The D is capital F capital, or you could read this thing. Maybe you read a CSV or do other things. So you could create the data frame yourself, or you can read it. Maybe use read CSV, read SQL, read all the read functions. Maybe read Excel. You still create a data frame from those functions. So, but if you use the pd.data frame, you can add in your data. So if you want to add in a NumPy array, so for instance, we use mp.random.randn supplying 5 and 3. So 5 is the number of rows and 3 is the number of columns. So in that case, you actually, when you put the data as the first argument to your data frame, you need to supply the columns too, so that you name the columns because it's all numbers. In NumPy, when you created the random, this thing is only going to give you numbers, random normal variables. So it's going to give you numbers and you need to supply the columns. So this is an instance where you create a data frame from NumPy. So the second one is from a dictionary. Okay. The second is from a dictionary. So when you want to create a NumPy array from a dictionary, you have to ensure a dictionary has a particular structure. It has the keys as the name of the columns and the values as the content. That's the values in the column. So you have the name of the column and the content of the column. The key is the name of the column, which is this, the name. The key is the name. You have the name of the column as the key. So you have the name of the column as the key, the name, the age, and the city. All these are the keys of the data frame. And then the values are the content, what you want each column to contain. So you have these, the names of the cities, the ages of the people, and these are the names. So you have this data frame, it goes, so you have your rows and your columns, of course, because data frames are two-dimensional, and that's what you use in CSV files, in spreadsheets. If you're using spreadsheets, it's all rows and columns. You have your columns, each variable is in a column, and each row is an observation, and you have all the data there. So if you want to create a data frame from a dictionary, it has to have this structure. And once it has this structure, you just read it like that, pd.data frame, and then you create your data frame and you can use it in whatever way you want to use it. So the next one is reading a CSV file, which is very important. There are many instances where you have to read a CSV file, just get your data. Most cases you get the data is given to you. It was generated by someone else and you just use it. So that's why it's good to read a CSV. So while creating this presentation, I didn't put a particular CSV to read. So that's why this code is not executable. It's just to show how to do it. So you pd.read_CSV and then you supply the file path. And the beautiful thing about Pandas is that if you're connected online, it doesn't have to be the file path of the CSV in your computer. You could actually supply the file path of an open CSV from GitHub or anywhere else, and it's going to read it for you, and you can continue working like that. So that's the beauty of it. Let's say you've seen a good CSV file on GitHub, you could just copy the link, copy the raw file, not just the normal link, and then you supply it as the argument to your read CSV, and it's going to read it for you once if you're connected online, and you can continue working like that. So that's why Pandas is a very powerful tool for data analysis because of all the things it makes easy. So most ways for you to get a data frame, the most common way is to read it, whether it's as a CSV file or read Excel or something like that, because that's where you hardly generate the data yourself unless in a few use cases. So the next thing is to look at some of the things you can do with Pandas. So some of the formulas we have in Pandas that we can use and when to use them. So the first is okay. Let's
Sir, your
generate.
mic is cracking.
Hello.
I mean, your mic is cracking, sir. It's somehow cracking. I don't know if it is from my end. I don't know.
Okay. I don't know what can cause that. Well, let's see. Okay, so the next thing is to simulate a data frame for exploration, just to look at what is possible with Pandas, what can be done when you're using Pandas. So, like I said, I didn't prepare a particular CSV, but just to look at what can be done using Pandas, how to the most important functions that you can use. We are going to generate our own data frame. So like I said, in most instances, you read the data, you hardly generate yourself. Maybe in some specific use cases, but majority you read it. So here we generate the data frame and we read it from a dictionary. So we have this column, student ID, name, and then you have the math score, the English score, the science scores. So you have the student IDs, and then you have the names of the people. So then part of the things you can do with data frame is to access the columns. You can access the column, you have a complete data frame. This is a small data frame, but you could have more. So let's say you want to get the name column. That's just the name, the column containing only the name. So you index it. So, and the way to index is to write the name of the data frame. And one thing you need to note is that you don't even need to name the data frame DF. You can name it anything. You can name the data frame student's course and then student underscore course, and then you do whatever you want. So it doesn't have to be named DF. This is just something that people use a lot. But if maybe you want you want what you're doing to be illustrative and you want people to understand, it's best to name it it's best to name it as something related to what you're working on. So if you're working on maybe students course, just name it students course, something small, and don't name it too long, and then it's hard to continue tracking it. So this to get the column, you can do it in different ways. So the first way is to index it using supplying the name of the column as a string. So we know our column is maths. So we write df and then we put square brackets and then put maths in string in quotation marks. That's how you get the column. So once you do that, you're going to have the column. You are going to get it. It will supply it back as a series. So this is a series. It's going to give you only the content of that column. That's maths. And that's why it will give you the name down. There is the name, maths, and then there's data type. It's int64. That means all of them are integers. So as always, it's going to optimize and make sure that the data structure only contains one data type because it's easier for faster calculation. And then the next one is if you still want to index it, let's say this is mass and mass is the third column. So you could actually index it using iloc. So if you want to index using iloc, you could say, okay, df dot iloc. So that means integer, and then you put your square brackets. Your this thing, you're going to just supply the column, and then that's 2 because the third column is 2. In Python, we do 0 indexing, so that's 0, 1, 2. So if you do df.iloc and then you supply 2, it's still going to give you the same math, and then you have the same results as this. It's going to give the same. The name will be math and the data type will be in64. And then the next thing is when you want to df.iloc, sorry, it's not just 2, is you put you put so you put a colon and then 2, because you're going to you put a colon and then a comma and then 2. Column means you need all the rows because 2 is the column. So when you do the iloc notation, you have to supply the rows and the column. So if you just supply 1, is going to be for the rows. So for the second one is for accessing rows, df.log. So the difference between both of them, in df.log, you're going to use the name of the name of the indices. So in df.log, when you use so for instance here you have, for this first row it has 0, 1, 2, 3, 4. That's the name of each of the rows. And then for the columns, you have student ID, name, maths, English, science. So if you want to index using df.log, so df.log 0 means you're getting all the items here, this place 0. So it's going to give you all. It's going to give you all. So the student ID is 1, and then the name is Ali, the math score is 73, the English score is 54, and the science score is 64. That's how you do. So it's giving you just that row and then all the contents. And then when you look at this, this is also the same. This is also a series. This is also a series because it's just one column. It's just a series. And then the data type here is object. The reason it's object is because you have a combination. You have 1 as integers, and then you have Ali as string. So it's going to convert almost everything back to string. So it has to be one data type. Then for the third one, you have df.iloc 1 to 4, and that means it's going to get from the first, from the second, because this is 0 indexing. So 1 means the second row. So this is just for rows. So difference between loc and iloc. For loc, let's say I want to get the second column. I want to get the second column. I will just use numbers. So instead of here, I use df.iloc. So for loc, you just df.log. If I want to use df.log to get the columns, I will still have to supply maths as a string because that's the name, maths. So the difference is you use the actual name in log, but in iloc you use integer. So if I know that I need the second column and the first row, I can just use df.iloc 0, 1. So 0 is second column, second row, the first row, sorry, and then 1 second column. So in iloc, you just use integers to index the data frame, and in log, you use the name. So for this our data frame that we are looking at, the names are student ID, name, maths, English, science. That's for the columns, and for the rows, you have the names of each of them as integers. That's 0 to 4. So in log, you just supply the numbers for the column and the strings for the numbers for the rows and the strings for the column. And then in ilog, it's all about using integers. You just use integers to do the indexing. And the reason this is important is that in pandas now, if you really want to, maybe you want to set the value of something, it's easier to just use log and ilog. In that case, you'll not be getting some of the warnings that it gives in pandas and saying you're trying to set a value on a copy of something. If you're working on it, you see. So it's good to understand how to index using log and ilog, especially if you want to change the values in your data frame. But you can normally index the same way, like using just the notation in the beginning, where you just put the df, put 1 square bracket, and put the name of the column in string. But if you use log, you also do that. But the first place before your comma is for the rows, and then the second place is for the column. And depending on whether you're using log or ilog, you either supply the actual names of the rows or columns, or you supply integers, that's the numbers representing this is the first row, second row, and then taking note that Python is zero indexing. So if you want the first row, you use 0 because it starts from 0 and not 1. So the next one is basic statistics. So if you want to perform basic statistics in Pandas on your data frame, you just use describe. And describe function is going to give you everything you need for the numerical columns. So for describe doesn't work for, so in our data frame, we have name, which is a string. It's not a numerical column. So describe will not work on names. Describe will not work on names, but it's going to work on maths, English, science, and then student ID, even though student ID is not something we really need to look at. So the count will give you the number, the total of each, how many observations you have in each of the columns. So you have student ID, math, English, all the counts. And then the mean will give you the mean, of course. You get the means of each of them. So for the maths, English, and science, the mean is important. So from this particular example, you know that the students on average are better in maths. They like maths more, they score more in maths, and then followed by English, and they are worse in science. So the average can give you an information on that. And the standard deviation too is a measure of the spread. So how far apart they are, like how is the spread of the data from the mean. So or the you look at it, the spread is more in English. So on average, you have more people further away from the mean in English than you have. So in science, it's more close together. Most of the scores will be closer together to the mean of 66. And then you have the minimum. So the minimum score overall in maths is 63. And then in English is 54. So it's supposed to view that they like maths more, they score more in maths. And then they have the quartiles. So the 25th percentile or the first quartile, and you have the 50th percentile or the median or the second quartile, and you have 75th percentile or the distant third quartile. So you have them all, and then you have the maximum. So the maximum will show you the number, the highest. So you have the maximum of 96 in maths, 94 in English, and in science you have 81. So using df.describe, it gives you an overview of your data. You kind of understand what is in it. So it's important to understand the data, and then you say, okay, I can use it however I like it. And even let's say you're using something else to do the analysis. Okay, you just find, okay, what is the equivalent for describe in what I'm using, and then you look for that function and use, and then you get your value. So it's really important to know why you're using a function, and then let's say you're not using Pandas, you're using something else to do your analysis, you'll still be able to do it because you understand the rationale for the function, and you understand what it means and why you need to understand why you need the function to be able to understand your data. So and then you have this thing. So that's described. The next thing is filtering data. There are instances where you need to filter your data, and then in these cases, it's mostly okay. You're using Boolean indexing. So you have df. So Pandas is the way Pandas is. You need to really understand how to use that. So you put your square brackets. So for cases like this, you understand the syntax is important to understand the syntax. You have the first square bracket for the main indexing that you use, and then this is the first square bracket. So inside the first square bracket, you now put what you need. So df square bracket mass, that means the mass column is greater than 80. So this is the filtering value you use. So you put this filtering value in your square bracket, and then that value also has a square bracket because you are going to filter out only the mass column. So you need to be careful while doing that. And then once you do that, you'll be able to get only the people with a mass score greater than 80. And then you find that you have the three of them listed. They're all greater than 80. One is 81 in mass, another is 86, another is 96. Then the second one is, okay, you want df of maths greater than 80 and then English greater than 70. So in Pandas, you can't use and. That's and, the way you do in regular Python. So you have to use the ampersand. That's this sign. This is the and. So you have to use this to do that. So, and then when you want to index here, of course, there is this first square bracket for indexing, and then inside the square bracket, you put in the values. So you need to remember to put the normal brackets, that's the normal rank bracket, while separating them if you're going to use AND. So it's important to understand the syntax for filtering. So you want to filter for different columns. So you need to understand. So it's the same data frame. We want to filter for math scores greater than 80, English scores greater than 70. There could be different reasons for this. Maybe you have prizes that you award for students who have this course. So you need to filter and see, and then you get their names. Say, okay, Bola, Dayo, and Ella, these are your prizes. So it's important to understand the syntax for doing this. So you don't use AND as AND. So, and there's also the OR, which is the vertical bar. So you have the OR, which is the vertical bar. That's like this if you want to use OR. So that means this or this. So in that case, either you have this score or that score. Whichever one you have, you'll be included. So that's the way filtering data, understanding that. And then there's sometimes you have use cases where you want to add columns or drop them. So if you want to add a column, you just assign. So df bracket total. So you don't have the total column before, but you want to have it now. So you just assign, and then you put equals to df bracket maths, and then English, and then science. So the total of the scores, you get this thing. It's going to give you the total. If you want, you could also program it, maybe give it an apply function or something, but this is just to make it very straightforward for easy understanding. So df total, you just assign it equals to the sum of the math score, the English score, and the science score. And in this case, you're going to have a new column assigned at the end as total to your original data frame. And then that's all. You have that. So the second one is, okay, you want to drop a column. So if you want to drop a column, let's say the student ID is redundant. It's just 1, 2, 3. You don't really need it. If it were maybe like matric numbers where you have letters and numbers that you continue using, maybe you can need that. But you found that you don't need the student ID. So drop it, you just put it df.drop, then you put the student ID as a string. You can either do that, or you can put as a list if maybe you have plenty things to drop. And then the axis, very important. Axis equals to 1. Of course, 1 is column, and then in place equals to true. If you didn't put in place, it's not going to it's going to give you like a new data frame that will show you this thing. But if you put in place, it's going to change the data frame you're working on. So depending on how, if you want to preserve your initial data frame, you would just leave the in place. But if you really want to change it, you don't need the student ID. There's no way you ever need it. Then you can just put in place equals to true. So it's going to change that. So here now, when I printed df under, there's no student ID column at all. So it changed the original data frame, and then you have this thing, the names, the math score, the English score, the science score, and then you have the total. So the next thing is okay, we want to sort and group. So there are different use cases. You want to sort, maybe you want to arrange them based on this course. You want to see who is the highest, who is the total. So let's say in this first instance, we sorted them based on the totals. So df.sort values, sort underscore values, that's for sorting. And then you have the column that you want to sort on, which is total. You could also sort on more columns. So anytime you want to sort on more than one column, you just put them as a list. So you just put a list, you put your square brackets, then you put the columns you want. So after this first column, I can put a comma and then add all the other columns I need. Then ascending is equals to false. So if ascending is false, it's going to sort in descending order, because originally in Pandas, when you check documentation, ascending has a value of true. So it's an optional argument that already has, if you leave it, you don't put anything ascending here, it's going to be true. And so it's going to start from the minimum to the highest. But when you're looking at student scores, of course, you want to see the top scorers. That's the highest people, the top students you have. So that means you need ascending as false. So you need to look at, that's the argument to add ascending false. So it's going to arrange them from the highest to the lowest. So here we have the highest as 241 and then the lowest as 190. That's sort values. So the second one is df.group by. So you have instances where, for this particular example, group by is not really going to be, let's say group by is not really going to be intuitive regarding, because the names, I'm just grouping by name and the names are the same. So for it to be intuitive, let's say we have class now. Let's say we have class here. We have class here, and then maybe they are in different classes. Some are in A, some are in B. So if you have some in A, some in B, and then you group by class, it's going to change the entire data into two. All the people in group A will be in one group. All the people in class A will be in one group. All the people in class B will be in the second group. And then when you do any calculation, it's going to give you the answer based on that group. So the reason for grouping, that's data aggregation, is for you to compare groups. For instance, let's say for this particular example, we have people in two classes, class A and B. Then I group by class here. I group by here instead of by name, I group by class. So I'm going to have two classes, class A and class B. I would like to see, okay, if I take the mean of their maths, which of the classes are better in maths, which of the class is better in math, things like that. So that's the importance of group by. It's going to change all your data. Normally, when you have a data frame, each row is an observation. So, but when you want to compare groups, okay, some are in class A, some are in class B. I want to see their performance. I want to see their average in English. I want to see the total, the mean, the average in the total. It doesn't have to be just mean. You could also use other aggregation functions. Maybe you're trying to get the standard deviation, or you're just trying to get the sum. Okay, what is the total they have, or something like that. Or you want to just get the maximum. Okay, what's the maximum for class A? Who was the highest in mass? Things like that. So you could do that using the group by function. It's very good for comparison. If let's say you just put the aggregate function, just put mean or max, it's going to give you just for everybody. And sometimes you don't, for everybody won't make any meaning to you. You would like to really compare and see, okay, maybe I have 6 classes. I want to see the classes that are doing well. I want to see the classes that are not doing too well, so that you see what you can do for them. So when you're dealing with data, you have to understand that there has to be a reason for what you're doing. You're just not doing things just like that. There's a reason. So I want to see the class, which class is doing better in maths. Maybe there is a particular teaching method the math teacher is using, and then we can look at implementing that same method for the second class so that they can do better. So there's always a reason behind the steps you take in your analysis, and that's why it's good to understand the data and take all these things, whether it's pandas, whatever you're using, as a tool. Because once you understand what you're looking at, the data you're working with, you know what to do. So you can sort because there's a reason. You understand that you want to see the highest, you want to see the lowest, you want to understand the differences between them. And then for grouping, you want to group by, and then you want to aggregate. I want to get the mean, I want to get the standard deviation, I want to understand what's going on. Why is this class better in math compared to the other class? So these functions are what you use for. And then, like I said, you can do them everywhere. So let's say maybe somebody's working on SQL, you use order by. If you use order by, you're going to sort them. And if you want to group to, there's still group by, and then you're going to do your things. So it doesn't matter what tool you're working with. It's just to understand how you want to use it, and then you use it. You can easily switch when you understand why you're doing whatever step you're doing in your analysis. So the next thing is data visualization. Of course, there are different reasons for visualizing. You need to understand your data and then use it. So you need to understand the data. So to visualize, you need to import matplotlib. So you import matplotlib, you import it using this syntax, matplotlib.pyplot as plt, or you say from matplotlib import pyplot as plt. So whichever way you want, then you do that. And then the next thing here, the second line is to set the index. So here you set the index as name, meaning that each of the observations will have the name of the person. So instead of you having 0123 as your index for each particular observation, you have the names of the students. That's their actual names as your observation. So you have, okay, this person's name is this person's name is Dio, this person's name is that, and then you have that. So as we can see here down. Then the next one is the title. So normally you set the title, plt.title will give you the title, you supply the title of the entire thing as a string. And then plt.ylabel, you do that. Then xticks and the rest you have. So, but here, the most important aspect here is that you use the plot function is from Pandas, is data frame. So the reason is not really clear is because I changed the operations. So the first thing is I set the index as name because I want the names to appear. So you have Ali, but then the next thing after setting the index, then the columns I needed. So maths, English, and index. So if you want to index, then you now supply a list. Of course, bracket and then a list. If you don't put the list directly of the columns as strings separated by this, that's the dot plot, because then in bracket kind is equals to bar plot you want. So it could be a bar chart. This one is a bar chart because I want to compare. I want to see I want to see how they compare among themselves. So the kind is bar. So then all the other things are just for you to customize the plot using matplotlib, because you can't do that easily just with pandas. So, but the plot function is using pandas. That's why we said plotting with pandas. So you want to set the title, you have to use plt.title, the y label plt.ylabel, and then pst.xtick rotation is equals to 45. This is the name. I want the name to be a bit rotated here, the way the names are rotated. And this is just because sometimes you have the names, you want the way the names will be displayed so that people can easily read it, especially when they are too long. If they are too long, you can't have them horizontal. So that's why I included the rotation part, so that in case, but for this, we could actually leave them without rotating them because the names are short. And then the plt dot title layout, and finally plt dot show, so that the plot will display. So finally you get the plot like this. But the reason for bringing this up is that from the data frame directly, you can call the plot method, that's df.plot, and then you put in the kind, and then as bar to do that. So there are other kinds and different plots a person can work on. So for this, we can see each person. Okay, this is the first person, Ali, on this thing. We can see the person's math score. He scored higher in maths. His English was the lowest, and then the science was a bit okay. And then when you look at in general, Bola scored more than Ali. And then you have the math score is more, the English was quite high, above 90. And then you have this thing, the science score, which is just a little below what Ali scored. So it's easy for you when you visualize, you are able to understand a lot about the data. You can explore the data and you can validate some of your assumptions about the data that you're working on. Though this is just a dummy data for description, but at least it shows people what can be achieved with the visualization. And that's why it's really good that with your data frame, you can easily use the dot plot method, and then you visualize to see the kind of things that you can do, to see what the data is about, and maybe look at what further exploration you need to do. From the visualization, you can make your hypothesis and say, okay, let me perform some hypothesis test to compare between this scores and that score and see whether there's something significant or something. Though this data is very everything, you finish the analysis, the plot can be part of your result too. Okay, this is what I found out, this is what I did. So a picture is generally 1,000 words, more than that. So you can show a lot from just your visualization. And that's why it's amazing that with the data frame object, you can easily call the dot plot method and plot it easily. And then when you want to customize, then you use the syntax here from matplotlib to do other things, because once you're displaying the plot, you want people to see, you want people to know that, okay, this is the title, and then You want everybody to know the labels, like the X and Y labels. If you leave it blank, people won't have any context on the visualization. They say that if people can spend more than 5 seconds trying to understand your visualization, then something is wrong. People should just see it and understand what it's about. So that's why you need the titles, the labels, and things like once somebody, oh, okay, this is a student's course, you're comparing them. So in summary, Pandas builds on NumPy and is used for flexible tabular data handling. It's important. It's tabular data, two-dimensional rows and columns. The rows are the observations and the columns are the variables or the attributes you're looking at. And then with data frames, your data manipulation is very easy. You can do a lot with it. You can index, you can filter, you can group, so many things. There are so many functions, there are numerous. There's no way you can know all the functions. You can only use the ones that you can, the ones that you need for your particular analysis purpose. And then let's say, even if you want to do machine learning and do other things, you really need to understand the data first. You want to understand the data to know, okay, these particular variables can have an impact on this. And okay, I can select these variables to train my simple linear regression model or something like that. And then another thing is, okay, you can easily use filtering, grouping, plotting to get quick insights to really understand what the data is about and what you can do with it. So when it comes to high pandas and all those things, there are a lot of syntax, there's a lot of things to understand. But the most important thing is to in this. Why do I need to group this? Why do I need to try and know the syntax? If you're using the basics, why you're doing whatever tool you're working with, and that's the same with Pandas as any other tool you're using. Just understand what it offers for you and what you need, because it can get so advanced that there are things that you want to do and Pandas doesn't have it. So you can even say, okay, why not add this and that, so that we can easily incorporate it into our workflows. So that's the basic thing about the pandas. So the next thing is just try different things, create your own data frame, explore filters, plots, practice all the functions, group by, mean, plot, and other things, just to understand even the data frame dot head and all those things to see the first few rows and things like that. With practice, you always improve and get better with the business. So that's all. If any questions, will be welcome now. Thank you.
Thank you, Mr. Lukman, for the wonderful session. It seems like there was a question. Somebody was raising hand. I can see. What's his name? Mujahid Nasir Hussain. Do you have a question, please? Mujahid Nasir. Is there anyone with a question, please, for Mr. Lukman?
Okay, yes, I have question.
Okay, go ahead, please.
Okay, sir. I know we can draw like
I can't hear you. Is that a network problem?
If we lost him, I may want to ask something.
Yeah, go ahead, please.
Okay, sorry,
Okay.
sorry, the what is not opening on my screen, but I may want to ask something. Recently, when using Pandas, I tried to upload my data frame severally, like I did about 50 times, it couldn't. I had to specify something which I got from LLM, that I have to specify the encoding. I must write encoding equals to Latin before it can upload. What could lead to that? What could be the problem? Is it from my data or what? Some of the data, if I try to upload with normal plain this thing, it will upload. But sometimes I will have to write encoding equals to Latin before it can upload. And even this one, first I got it, I think from, what do you call it? What's the name of this place? The one that we were using before LLM, Stack Overflow. Oh, can't you hear me?
Okay, sorry, I was muted. So when it comes to things like this, it depends on the source of your data. So normally the computer will use a regular encoding type depending on the content of your file because it has to read the string in the file. So for normal documents, you don't need to supply anything because most of the encoding is the regular UTF-8. It's just going to use that and then do that. But when the somehow from the source where you got your data, the encoding is not the same, or the computer is the program is having it difficult to understand the encoding, then you have to supply. Otherwise, it's going to read it differently. And that's how it always is. Depends on the data. There are even times when you want to read your data frame and then maybe you want to read a CSV, and then maybe instead of using commas, the person use tabs. So you have to actually supply tabs as your delimiter. Otherwise, it's not going to data, read that file for you. So it depends a lot on the nature of the file
You
and the
know,
source.
I am in life science, so our data is normally what we got in the lab.
Okay. So
Mm.
it depends on how the this thing is done, because it's the computer uses something. It automatically uses the regular encoding, but if you can't read anything with that, then you have to supply the encoding that is gotten, and it depends on the source. So since you already know the source, then it's easy for you to just supply it as long as it's the same data. Like when you read it, you see what you want to see. So once that's done, the important thing is to know that, okay, while reading it, I have to supply the encoding
The
because the
encoding.
way the data is generated is different. So that's this thing.
Okay, now I understand. Thank you.
All right. So the other question is about look. Okay.
Hello.
Yes. Yes, sir.
Sorry, Mr. Lukman. Thank you for responding to the gentleman regarding the data encoding. I would like to please add another point to his understanding. When it comes to compatibility, you'll find out that data encoding ensures that data from different sources can be understood and processed together. Because I heard you saying that you are generating your data set from life sciences, right? From maybe,
Yes.
is it from biology, right?
Yes,
Okay,
human neuroscience.
okay, neuroscience.
Yes.
But my question is, are these data generated at frequent time interval or at in real time?
No, it depends on the project. Sometimes we only create, for our people in the labs, we create a Google document for them. When they get something from the machines, they should just type it directly into Google document so that the Google sheet, so that we can have the table. And sometimes it is the CSV file directly exported from the machine that we normally upload to make analysis.
Okay.
Yes.
So I think
Sometimes the data is sometimes even coming from the sequencer.
okay.
Yes.
Okay. But I think based on your explanation, it goes down to compatibility issues.
Just as he explained, yes.
Yes. Thank you very much. Lukman, you can carry on.
Oh, okay, sir. Okay, sir. And then I think the final question is about lock and ilock functions in pandas analysis. So for lock and ilock is just a unique way of indexing so that you can easily index your columns and rows in your data frame. So you have a data frame, and you can easily index and get the content of the data frame. So let me just try and display an example. So we have, let me use the same example we did here. So we have a data frame like this. We can so this is my VS Code. So you have your data frame like this. Oh, okay, wait. Okay. So I need to import pandas as PD. Oh, okay, what number two? What numpy? Sorry, as MP. So once we have that, so we have the data frame like this. So we can see student ID, name, math, English, science. So when you want to use, the first is log. So using the log method, so we write it. So this thing, one of the most important thing is while assigning. So let's say I want to assign a value. If I just use regular indexing to assign, it's going to give some errors. When you want to use log, let's say I want to see. So in log, the first thing you supply is the name of the row. So in this particular data frame, we have the names of the rows as 0, 1, 2, 3, 4. So if I want the first row, I'll put 0. Then the next thing is the column. So I want the column format. So the names are math. That's MATH. So after 0, I put comma, and then my string, name of the column as a string. So df.log 0 maths, I'm going to get 87. This 87. So for ilog, the second one, you use integers for the indexing. So for ilog, you use integers for the indexing. So the same thing, I want the score in the first row. So I df.ilog. So the difference is that for this one, though the names of the rows is still an integer, it won't show anything. So I'll still write 0. So ilog only accepts integers. So for mass now, I have to count. So this is the first row, the second row, the third row. That's the first column, 0, 1, 2. So I have to supply 2 as the column name, and then I will get the same score, 87. And apart from that, you could also use a colon to do more than one. So I can get, okay, the first two rows, that's 0 to 2, and then for the column, I can put a colon and then put up to this thing, science or something like that. So once you do that, you can do the indexing and you get what you need. Like you can do that. So for this thing too, the same thing. So 0 maybe to 2, but this one 2 to 3, this thing. And when you supply when you're doing for log and ilog, you have to understand the differences when you're slicing more than one column. So for one column, for one, you're going to get, let's say, 0 to 2. It means it's all inclusive. You get up to 2. Math to science is all inclusive. That's when you're using .log. You're actually using the names of the rows and the column. But ilog, you're using the index, you're using the integers. So this is the first row, second row, third row. This is the first column. You don't care about the name. So maybe you know that the math score is in the third column. So you just supply 2. So when you're using that, it's used the regular Python slicing. So meaning that the ends are not included. So if you put 0 to 2, it means it's only going to put 0 and 1. So that's the difference. And then the syntax is that you put the row first, and then you separate with a comma, and then you put the column. So whether it's ilog or log, that's how you do. The log is just for you to use the actual names of the rows and column, but ilog, you use the integers, the allocation, whether it's the first row, the second row, or the third row. Just noting that there's zero indexing in Python. So that's the key differences. Hope it's clearer now.
Is there anyone with another question again, please?
Okay, I think that's all.
Okay, so in the absence of question, I will still emphasize on the issue of the attendance, please. Starting from next week, we are going to send an emails to the assignment that you're going to work on for the submissions for this week. So including the names of the mentors that you're going to submit the assignments to with their contacts email, you shares your detail with them, though depends on how you arrange between you and the mentor on how to submit the assignments to them. So we'll be reviewing weekly and be giving the feedback, seeing that the numbers of the fellows peers are very few. So the commitments are very important. And also coming to session is very important, is what makes us to issue a certificate of graduations and also to consider you on the next stage of the fellowships, that is deep learning with PyTorch. So it's highly recommended that you should be coming to the sessions and being engaged into. So in the absence of that one, I will forward it to Doctor in case if he has something to say. Dr. Sir, if you are present.
Thank you very much. Yeah, that's all. See you next week. Okay, by the way, I think as I said, for today, because we mixed last week, this week is for you to practice the Python, the NumPy and Pandas, which we already have the exercises on the GitHub. So you are free to practice them and ask questions to the mentors. And we'll also reach out to you about sessions with mentors on how to walk through the exercises. So today is only the day I think we meet today, this week, and next week you meet Dr. Mahmoud for visualization. Yeah.
This is a reference.
Yeah. Thank you very much.
I don't know if you are going to teach us GeoPandas.
No. So you can take over. So our own aim is to introduce you to the basic, to what we can do. Then you can, when we are, confident that when you get the basic idea, you can learn much more. So we are not going into specific details because there are many things with pandas, not only GeoPandas, but tons of things. In fact, you can see there is a book on pandas. And it's unfortunately not feasible for us to cover everything about pandas. So yeah,
it's too bulky.
it's too bulky. But when we give you like the basic, then you can, learn more on yourself by going through the book and other stuff. That's why, for example, we share a book about, something that you can go learn deep if you go through that book.
And also, if I may, I may wish to have more mentors. Though I am not in the field, but currently I got a visiting professor position at University of Chicago on data science stuff. I have been in life science all my life. Just recently, I started to explore, what do you call it? The analysis stuff using Python. And fortunately, I got that position, which I think I need more mentors in machine learning.
Yes.
I'm going to be involved in, do you know the Wendy Schmidt Fellowship?
I know.
Yes, so I have been selected for the fellowship. This is the first time they are expanding it to Nigeria, and locally enough, I was selected to the fellowship. So my attention is coming back to machine learning now.
Yeah. So one thing I would advise is, are you doing the our own certificates from DataCamp?
No. I've been very busy.
Okay, my question is, are you fellow in?
I'm
Are you
still
fellow?
in the UK doing other things which are actually wet lab works.
Are you fellow in Ario Data Science? Do you finish our first cohort?
Yes, I've attended many, but I was unable to do any. But I have gone through what you have been doing, because most of the time,
No,
even
listen. The question is, are you Ario Data Science fellow? Did you finish Python fellowship?
partly yes.
Were you given a certificate?
No.
Okay, so one thing I would advise is that maybe you might have missed our session, and also maybe you are not full fellow, which you may have some gaps. But
Yes.
what we can do is reach out to our Bala Mariga Abdul our coordinator. He can enroll you if you are not into data camp, which you will start, learning a lot of things, which will help you a lot. But we can keep chatting more. If you are available, you can join our Discord, and then we can discuss more stuff there.
Okay. So hopefully, no problem. I will contact them.
Yeah. Maybe you can, if you are in Discord, you can chat. You can chat me or any of these men, us. We can provide you with more support and direction. Thank you. Anyone with question?
I really need that. I really need it.
Anyone with question? Okay, so thank you very much for coming, and we see you next week. Bye-bye.
Thank you, Doctor. Well done, Lukman.
All right,
Thank you, sir.
Thank you. Bye-bye.
Thank you, Doctor.
Oh, Bala, thank you.